See here we have two spheres. This one has 1, 2, 3, 4, 5, 6 positive things. So 6 positive things, sorry. And then it has 1, 2, 3, 4 negative things. So, Talefu, tell me, what is the net charge on this object? Net charge. It has 6 positive things and 4 negative things. What's the net charge? Do you take accounting? You had a business or what, EMS last year? Yes? We did accounting and business a bit? Yes? No, let me ask someone that takes accounting this year. Who takes accounting? Okay, wait. Let's say who is next to her. Let's say who? What? Please explain to her what is net. Like your net salary, your net, what's Vince? Vince, your net income, your net, what does that mean? You have brutto and you have net. You've done that last year as well. Yes, you have. It's one of the basic things. No one in this whole class. Sure, people, this is a problem. When, I can't believe I have to explain this. Right, you have a brutto salary one day. That is how much you get. Let's say you get 100 Rand brutto salary per month. And then you have your net salary. Brutto salary is what you get. Net salary is what you have in your pocket after you've subtracted all of your expenses. Okay, so you have to pay electricity and what is it that you have to pay the government? Tax, thank you. Tax, medical, pension fund, blah, 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 blah. And after all of that, you only have 50 Rand in your bank. So brutto is what the big thing that you get, pure income. And then net is after you have deducted everything. Okay. You did this last year. Where you've added things and subtracted things, and then what's your net saldo? Yeah. Alrighty. Anyway, so net charge means you've added and subtracted everything, and what do you get at the end? Yes. Yes. Nah. 6, 4. What is the net charge? Yes.
So I'm supposed to say positive 6 minus.
Yes. Negative 2.
Positive. Oh, no. But,
Positive 2.
I mean, is it positive?
You have 6 Rand and you spend 4 Rand.
But before it's negative.
Yes.
So positive plus negative.
You are thinking about times. Positive times negative is negative. We're not timing, we're adding. Net means to add, the sum of. Alright? So the net charge here is positive 2. So this sphere is positively charged. Then this one here we see we have 1, 2, 3, 4, 5, 6 positive things and absolutely 0 negative things. Okay, so what will the net charge be, Lesego? Positive 6. Alright, so we can see we have two things. They are both positively charged, but they are unlike, meaning they are not similar. It's very positive and little positive. Okay, so it can be negative positive, it can be neutral negative, it can be anything, but unlike charges, let's make a note there. Unlike charges can be positive and negative, but that is actually opposite charges. Unlike charges can also be very positive and little positive. They are also unlike. They are not the same. Or it can be, let's say, neutral and negative. Okay, so unlike charges just means not identical, not exactly the same. So here we have unlike charges. Okay, unlike charges. And they touch. When they touch, there's a transfer of electrons. Yes? Okay, now, Karabu, from where to where will the electrons transfer? So, let's say this is A, this is B. Will it transfer from A to B or B to A? From A to B. Why? Because it has more negative things than what B has. B has nothing to transfer. You can't transfer positive things, then you have an atomic bomb. Okay? So because this has more negative things, it's going to transfer from there to there. How many Carabello will transfer? All 4. Oop, go on that side. Then this one has 0 and this one is 4. 2, 2. They transfer until the charges on both are equal. Okay, so this one has 6 positive things. This one has 6 positive things. That's what's given to us. It can't change. You can't change the number of positive things, then you have an atomic bomb. You can only transfer the negative things. So we said that 2 of the electrons will transfer. So that this one has 2 and this one has 2. So if you now look at the charges on both, or the net charge on both objects, this one has 6 positive things, 6 positive things, 2 negative things, 2 negative things, 2 negative things. So this one's net charge is positive 4 and this one is positive 4 until they are equal. Okay, so here we have the law of conservation of charge. Now let's just stop there, Carabello. Conservation. What does that word mean? And what does that mean? To keep something isolated, to keep something protected, to cause something not to change. Okay, so we have like the conservation of rhinos in South Africa or in Africa. Why? Because the rhinos are being poached, so we want to keep it conserved. We want to keep it protected from the outside. Okay, so conservation means to keep something the same. Okay, so it says there the net charge. Here you see the word net. What does the word net mean? It means the sum of the protons and electrons. When you add all of the negative and positive things together, what do you get? Okay, the net charge of an isolated system. Genevieve, what does isolated mean? It means alone. There's no external things coming in from outside. So we are only working in isolated systems. We do not want an outside force or whatever to take away an electron. We want it to be protected. Okay, so the net charge of an isolated system remains constant during any physical process. So it just means if you have 2 objects and they touching is a physical process, then yes, there will be a transfer of electrons, blah, 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 blah. But if we check how many protons did we have here? 12. How many do we have here? 12. How many electrons did we have? 4. How many do we have here? 4. So even though there was a transfer of electrons moving, the net charge that you have is still the same. Are you with me? Okay. Right, so the net charge of an isolated system remains constant during any physical process. So in other words, it says the sum of, Atlehang, what does sum mean again? Plus. The sum of means the plus, the adding. The sum of the charges at the beginning must be equal to the sum of the charges at the end. Yes.
It's a must for the net charge to be equal.
Yes. All right. So we said at the top, when they touch, there's a transfer of charges until they are equal. So we now have a formula to calculate this new charge. There's that formula. All right. Now that formula again is not on the data sheet that you currently have, but you will get it in a test or in an exam. Okay, now let's say quickly again in our little story. You know when people go into business, they have an option, what type of business, a lot of businesses. You can add all of your equities, all of your assets together, right? But then you also add all of your liabilities together. Okay, so let's say me and Ntebeleng goes into business. What are we selling? Okay, maybe clothes and stuff like that. He, Ntebeleng is rich. He says, I'm bringing 1,000 rand to the party. I say, you know what, Ntebeleng, thank you very much. I do not have money, but I'll bring the brains. So I'm actually in debt. I am bringing debt of 200 rand. Right? Now we go into business and we realize, this is not going to work, and we dissolve the business. Now we must split our shares. How many people were there in our business? 2 people. So how much do both walk away with? Nie in your kop. 1,000 minus 200. Divided by 2. Yes, it is cheating. But I won't, so I don't care. Right, so this is the same thing. So when 2 charges come together, it's like they add all of their eggs, all of their charges in one basket, and then they split it up into 2. You get it? Right. If there's 3 charges, then you add all of it together and you split it by 3. If there's 4 charges, you're going to split it by 4. All right. So this formula here is not fixed. If there's 3 charges, then you're going to divide it by 3. If there's 4, you're going to divide by 4. All right. Let's see how it works. It says 2 metal balls of equal size. Now, equal size does not mean equal charge. It just means their size is the same, not how many things are on there. Equal size carry charges of 2 times 10 to the power negative 11 coulomb and negative 8 times 10 to the power negative 11, respectively. They are brought into contact and then separated. What is the new charge on each ball after they have touched? Not have touched it, just after they have touched. Okay, so our first charge is 2 times 10 to the power negative 11. Our second charge is negative 8 times 10 to the power negative 11. Right, we want to get the new charge, so it's charge 1 plus charge 2, the sum of the charges, divided by 2. So it's 2 times negative 11 plus negative 8 times 10 to the power negative 11 over 2. Where are we with our questions? Omulemu, in your head. 2 plus negative 8 gives you what? Divided by 2. Negative 3 times 10 to the power negative 11. Test, if you do not believe me. Remember, I say, do you trust anyone? No. That also includes me. You must think for yourself. I am a human being. I make lots of mistakes. Sharp, sharp? Alright, and remember to put in the coulomb. Coulomb. Okay, then grade 10s. I asked you, I think I said that for yesterday, but I asked you to bring a ruler and an eraser. Yes? You can take that out. Okay, and I'm on page 3. On the page is the forces between charges. Now this is something that you all know. If you don't know it, you have a problem. You know that positive and negative attract. Yes? Negative and negative repel. Okay? Or positive and positive repel. So that's just what it says. It says when you have two forces, two charges, they exert a force on one another, and that force is proportional. Will depend on the charges. They repel or they attract. Now, this is an introduction to grade 11. So I just want you to think ahead for grade 11. But before we get that, like charges repel, opposite charges attract the force. The symbol for force is F. Okay? I want you to think, when you think of the forces, I want you to think of magnets. Magnets. The bigger the magnets, the bigger the force. Yes? If the magnets are close together, you feel the force. If they are far apart, you don't feel the force. Okay, so same thing here. Right, next we're going to look at polarization. Okay, and that is why I asked you to take out a ruler and an eraser. For the eraser, I want you to take it and then do this so that it makes these little hairs. Okay? Then I want you to take your ruler. So obviously share between each other if you don't have your ruler here or eraser or whatever. So you're going to take your ruler and put it under your nice sweaty armpit. Those that have jerseys on, it will work better with you. Then I want you to bring it closer, and what I want you to see, as some people this will not do good, is that the pieces stick out. Look at that. It depends what type of ruler you have.